Hello to everyone guys, this is a new video. In this new video we are going to create the follow camera script for our boat. That is a very simple script that will add a lot of more feel to your game. So let's start. The first simple task is to drop the main camera inside the player game object, because we need to follow him, and put there some correct value. I already done this, so I know what value I need, but you can experiment to see what camera angle you like the most. So this will be my resting camera angle, while the moving camera angle will be different. How do we change this? Well, we create a script, and we call it camera script. We drop this inside the main camera. Okay. And we open the script. So the first thing to do is to delete these commands that are unuseful, and to create some variable. The variable will be the position at a resting state for the boat, so the basic offset, and the offset where it's moving fast. So vector free velocity offset. Yeah, I'm very creative with the variable's name. And then we need a multiplier to make this movement faster, and other or slower multiplier. We need the reference to our player game object, and to assign this reference. This is very simply done with the game object that find player. This is the name of our game object that we want to find. We can do this also with other ways, such as searching for tags, searching for IDs. There are a lot of ways. This is fast and easy, so I use this in this script. So for the update, what we're gonna do is to lerp the value of the local position. So the transform.local position will be a lerp from the vector free namespace. Inside this, the starting position for the lerp will be the starting local position, while the vector to reach will be the offset. That is the basic offset of the boat, plus the velocity offset times the velocity magnitude. So we get to the rigid body of our player. We get from this the velocity and then the magnitude, and we will divide this by the velocity multiplier. You can also multiply this by the velocity multiplier, just invert the value. So if in this case I use 10 as a velocity multiplier, the total offset will be 1/10. If I multiply the velocity multiplier, I need to write 0.1. I just find this more easy to understand by dividing it, because generally we will go slower. And for the time variable, we use just the delta time. So as we can see, we can insert our values. So the basics are what we have right now, and the offset where we accelerate can be like -20, and we go a little bit lower, -5. Okay, and the multiplier we can leave it to 1 to see the normal effects without moving this. So there is a problem. So The problem probably is that the velocity multiplier is too much, so the velocity shifts the camera too much. So I try with a higher value, a lot higher value, and this should work. If obviously, if the joysticks work, okay. As you can see, when we accelerate, the camera moves. Now let's fix the value. Maybe this was 5 and not -5. Okay, yes. And as you can see, when I accelerate, when I reduce the velocity, it counts near the boat. When I accelerate, this goes way beyond the boat. And this is a simple camera script. Now we can also add the rotation effects. So let's go inside the script. So we need 3 variables. Now we will use a different approach to this, to move this. So the vector 3 will be, we will call this resting angle, where when the boat is still, and the other vector 3 will be the moving angle. Now, instead of multiplying and using only a single lerp, this time we will use a limit, in which where we surpass this limit, we go to the other type of angle. So we go just the velocity limit. Perfect. Now, inside of the update, we go with the if statement, and if the player.rigidBody.velocity rigidBody dot velocity dot magnitude is more than velocity limit, is less than velocity limit, we use the resting state. So transform.local rotation. Remember to use the local rotational position, because we are in a local space. Otherwise this will go crazy, really crazy. And we can just use to this quaternion.lerp, and instead of this using the quaternion Euler. So the starting position will be just transform.local rotation. Position rotation, I'm making a lot of errors, sorry. Quaternion.Euler, and we use the resting angle. And for the time, obviously, time.delta time. Same things goes for the other, but we just changed there to a moving angle, and there it's more or equal, greater or equal. So maybe we apply also the value. The velocity limit, just put 10, that is a good velocity limit. For the basic angle is 3590, as we have right there. For a velocity angle we use a lower angle, so maybe an half, 15. And let's see that if the joystick works, obviously, and the joystick doesn't work, okay. If I accelerate, the angle goes lower, really lower. If I release the button, this goes higher. It's very easy. Maybe the angle should be a little bit greater, maybe 25. Okay, and maybe not -5 but 10. So this, okay. Okay, now it seems more reasonable to use 15. I forgot to rechange the Y value. Okay, and that's perfect. And I'm making a lot of error in riding the boat. So probably this is the end of this series about the motorboat race, because we built the main system. Now to finish the game is just polishing, and I can't help in polishing with tutorial. So what you're gonna do is that we are gonna interrupt this series, and probably I will not do a lot more tutorial series because it's really boring to do them, and I find them pretty unuseful. Maybe it's more useful to talk about game development without a need for doing tutorial. So probably the aim of this channel will change. Probably will be neither on game development. We will move also in other type of development, such as web development, web game development, and a lot of more stuff. Also this, because I don't want to leave Unity, but doing only this is very boring. Let's put this way. So thanks for watching, and we will see you the next time.